Hello, it is time to check our bell work for Wednesday, March 3rd. If you weren't able to print this, then in your spiral, continuing along from before, you can use the same piece of paper and just write down underneath what you have already. Write down Wednesday 3/3. And for this, for 1, 2, and 3, you don't have to write out all the words if you're doing this in your spiral. You just have to write the equation that you solved and then solve it. For 4 through 7, you should write down the problem. But I'm not going to make you write out all the words for this. You can just open up the file that's attached to this, look at the problems, solve them in your spiral, and check your work. All right, here we go. It says to write and solve an equation for each. Write your answers as mixed numbers in simplest form when possible. If your answer doesn't become a mixed number, you don't have to try to force it. It's okay. That's why I said when possible. So Bobby equally divides 7 pounds of bird seed into 4 bird feeders. How many pounds of bird seed are placed in each feeder? So do you see how it says he equally divides? I'm guessing this is division, right? So think about this. What is he dividing up? Is he dividing up the bird seed or the bird feeders? If you said bird seed, you are correct. He's taking the 7 pounds of bird seed and dividing it up between the 4 bird feeders. So this problem should be 7 divided by 4. So if we want to know how many pounds are placed in each feeder, I can use, because I can see, well, this isn't going to come out to a nice whole number. I can use the inverse of this, which would be 7 times 1/4. And if you have 1/4 7 times, you have 7/4. If you jumped right from here to here, that's fine, because it says 7 divided by 4, and so does that. This can be written as a mixed number. 4 goes into 7 one time, and 4 times 1 is 4, and there's 3 more to get to the 7 out of 4. So 1 3/4 pounds would go into each bird feeder. Okay, Jason has 10 suckers. This is 1/3 of the number of suckers that Jackie has. How many suckers does Jackie have? So you should probably ask yourself the question of, well, who has more? Okay, I think that will help for this. Jason has 10, and this is 1/3 of the amount that Jackie has. So if Jason has 1/3 of the amount that Jackie has, and 1/3 is less than 1, right? That means Jackie's going to have more. That'll help us in the end when we go to check our answer. So coming up with an equation for this one, I feel like sometimes it's a little bit tricky, but let's go back to the beginning. We know that Jason has 10, and it says this is. So that means that 10 is 1/3 of the suckers that Jackie has. Now that of, we learned, especially in our number talks, means to multiply, right? So what Jason has, 10, is 1/3 of what Jackie has. How many does Jackie have? We don't know how much Jackie has, right? So we can use J for Jackie. So if I was trying to write an equation for this, it might look something like 10 is equal to 1/3 times the number of suckers that Jackie has. So this is what Jason has, 1/3 of what Jackie has, and we don't know what Jackie has. So in trying to solve this one, if I want to know 1/3 times what is 10, remember we can use division. We can use an opposite operation to help us figure out what J is. So if I want to know 1/3 times what is 10, I can take 10 divided by 1/3 to get that. Just like if we had whole numbers, okay? Remember, you've done this a million times. You've just done it with whole numbers instead of fractions. So it's the same idea. So in order to solve 10 divided by 1/3, I want to know how many 1/3s there are in 10. I can use inverse operations. So instead of 10 divided by 1/3, I can do 10 times the reciprocal of 1/3, which is 3/1, or 3. And 10 times 3 is 30 suckers. And let's go back and see if this makes sense. If Jason has 10, and that's 1/3 of what Jackie has, is 1/3 of 30 10? Sure is. 10, 20, 30. There are 3 10s and 30s, which would make it 1/3 of it. Okay, number 3. Chelsea is decorating for a party. She has 40 feet of lights that she wants to hang on the wall. She plans to place a command hook every half of a foot. Those command hooks are those little things that stick on the wall with like the little hook thing on there. But command hook is the official name. So she wants to place one every half of a foot. How many command hooks will she need? So she has 40 feet, right? And then every half of a foot. So don't I kind of want to know how many halves there are in 40? What would that be? If you said division, you are right. And what are we starting off with? What do we have? We have 40 feet of lights. And I want to know how many 1/2s there are in 40. That's division. So in order to solve this, I'm going to use the reciprocal. I'm going to multiply by the reciprocal. So 40 times the reciprocal of 1/2 is 2/1 or 2. And the answer is 80. She will need 80 command hooks. Okay. Now for 4 through 7, a little blast from the past, but this is going to help us when we're trying to figure out, is our answer greater than or less than? It'll help us with our problems from this week. So I ask you to compare using less than, greater than, equal to. Now if you are writing this in your spiral, you should write the problem. You should write number 4, 4/9, 2/5 with a space in between, and figure this out. So we know that if we're trying to figure out what's greater, less, or if they're equal, that we need to have a common denominator. And we get a common denominator the same way we do when we add and subtract. I'm going to look at the 9 and I look at the 5. Is there something I can multiply 5 by to get 9? No. So I would multiply each fraction by the opposite fraction's denominator. When I do that, I end up getting 2 fractions with a common denominator. So instead of trying to compare 4/9 with 2/5, I can compare 20 45ths and 18 45ths. Now the denominators match, it's easy to see, well, 20 out of 45 is more than 18 out of 45, so 4/9 would be the greater one. For number 5, 1/10 and 1/8. Now with this, these are unit fractions, right? And when you're comparing unit fractions, you don't have to come up with a common denominator. We can just recognize that. If I cut something up into tenths, those pieces are going to be smaller than if I cut them up into 8. Like picture I'm sharing something and cutting it up into 10 pieces, and here I'm sharing the same thing but only cutting it up into 8. So 1/8 would be greater than 1/10 because these pieces would be larger. Now, if you just use the strategy of, okay, I just multiply by the opposite fraction's denominator, then you would have 8/80ths compared to 10/80ths, and you would still see that the 1/8 is greater. Or maybe use the GCF and you multiplied this by 4/4 and this by 5/5 because 40 is actually the lowest number that they'd have in common. No matter how you did this, 1/8 would be greater. All right, 5/8 and 1/2. Now with this one, you could change to get a common denominator. Or you could say, okay, well 1/2, well 4 out of 8 would be 1/2, right? Isn't 5 out of 8 then more than 1/2? Yeah, so 5/8 would be greater. Now, if you went ahead and said, well, 2 times 4 would give me 8, so this would end up being 4/8, you would still see that 5/8 was greater. So it doesn't matter which way you do it, but you can use your number sense and things from our number talk to figure this out. All right, so 2/3 compared to 5/6. I know that 3 times 2 is 6, 2 times 2 is 4, 2 times 3 is 6, and 5/6 is greater. You could have looked at this as, okay, well, thirds are bigger than sixths, right? If you're only sharing with 3 people versus 6 people. So this is 1/6 away from a whole, and this is 1/3 away from a whole. 1/6 is smaller, so that means it's closer to the whole. You could use fractional reasoning for that one as well. So if you did, great. If you didn't, great. Doesn't matter. As long as you got 5/6 for your answer. It's not my way or the highway. All right, good luck on the rest of your work for today. Thanks for watching.